Okay, sorry about the email sent yesterday. I need to go to the hospital this Wednesday, so our quiz is moved on to Wednesday. Still the same 10 questions, but on Wednesday. So today we will learn this. I think this is actually the last chapter we will test in this course. We will learn that search, binary search, chapter 25, but we won't test it in the last quiz. So this will be the last chapter we learn this basically this term. Actually, we have already talked about list, stacks, queues, and all these things in previous chapters, but you can see Java has already implemented all these class for us. We can just import it and just define it, declare it directly. But then what does this chapter do? Chapter 24 basically just try to implement every class by ourselves, assuming we don't have all these linked lists, all these things. So we need to do it by ourselves. This way, through this kind of implementation, we will be more familiar with these data structures and how to use them in future. First, let's see how can we implement list. We know that we can do it in using an array or using linked list. The difference is for array, the size is fixed. So if the capacity exceeds capacity is exceeded, we have to create a new one. But for linked list, we don't have to do that. We can just, because each value is saved in a node, and all those nodes are linked together, we can just do it dynamically. If we want to implement a list using an array, there are two operations. One is insertion and one is deletion. That's commonly used in this list manipulation. But if we do it in array, if we want to insert something, for example, in index I, we have to move everything back to the next location on the memory and then insert this element to this location. Otherwise, it will be, it will just replace the value in the previous location. Similarly, if we want to do it deletion, we need to remove this element first. Actually, we can print out this element. And after that, we have to move everything previously to the previous location. This will waste a lot of time. Basically, we just want to get an element, but we need to do all these kind of operations. So these are all the methods we need to implement if we want to write this array list class just by ourselves. We have remove, set, and we also need to check if object contains in this list, and also get the element in that index and find the index of the list of the element, and also we need to implement the iterator if we want to use this function. So I will talk about how to do it, add an element and remove an element today. And for all the other methods, I will upload the scripts to Moodle in case you want to check it out. Basically, I think the idea is you just need to understand what everything is saved if we want to use array to save a list, and that's it. Because in the future you can just use it directly. It's already defined by Java. So these are the two methods for add and remove an element. So you can see if we want to move, if we want to add an element E, we need to first make sure the array has enough capacity. And next time, after that, we just need to move every element to the next location. And this time we start from the last one and just go backwards to the specific index. After everything is moved, we can save this element to this specific location. Similarly, if it's removed, we can just get the element at first, maybe print it out, because you can see this function has a return function, because usually this remove function method also will get this element for you. But after that, we still need to start from the current index and move everything to the previous location. That's how we can implement these two methods using Java. Of course, this is very time consuming. Better ways we can use linked list. I draw a diagram on the whiteboard previously showing how linked list is implemented. I mean, how the structure is. Let's see animation today. It should be more clearer. So you can see in a linked list, there are two nodes. One is a two pointer, like one point to the head and one point to the tail. It will help us to get the element in that list. We can initiate maybe 3, insert again. For you can see each time a new cell is created and a number is inserted and a pointer is, I mean, a link is connected between the two cells, and that's how we can just create a linked list. But remember, every time this tail has to be pointed to the last one in the list, because in a linked list there is actually no index. Everything is randomly saved in the memory. If we can, assuming we want to get 4, we need to go from head first and next, and just reach to that location. Although, I mean, if because we implement a list, we have an index there, but I mean, all these things they saved on the memory. There's no index. We have to mimic like if I want to get the element in the index 3, assuming this y is 0, we have to using a for loop next 3 times and get that specific element. You can see similarly we have these methods for linked list, but there's one difference. Here we have this add first, add last, and also remove first, remove last. These 4 methods is mainly because it's if we remove an element at the beginning or at the end, it will be different from remove an element in the middle. Because if we want to remove the first, we just need to change the head pointer. And if we remove an element at the end, we just need to change the tail. But let's see. Yeah, you can see the add first, we want to add something at the beginning, we can just save the head node to the like. Let me do it. Let's see, we have a linked list. There are 3 cells, they all linked together. And this one is a head. Assuming we want to add something with a new node here at the beginning, we have this new node. We have to first point this head pointer to this new node, which is just the, yeah. So, oh, sorry, that's actually, he did it. We first point this one, I mean, create a link between this one. So this new node is next is the previous head. And I mean, this link is created. Next, and after that, we can point the head to this new node. So now the new node is a head. It's like 2 steps. First, create the link, and then second, change the head to the new head. That's how. Similarly, if it's add something at the end, we can first. This is a new node. We can see the previous head. I mean, sorry, previous tail is next is pointed to this new node. This way, the connection is created, and after that, this one we will say this one is a new tail. Like the previous tail is next is a new node, and the new node is a new tail. That's kind of how we can add something at the beginning or at the end. Once we have these two functions, if we want to add something into this list, we can check like if it's from the beginning, we just use this one. If it's at the end, we just using at last. But if it's in the middle, it's a little bit complicated. We have to, assuming this is a new node, we have to break this previous link and point this one here and this one here, like increase two links to make all the nodes is connected. You can see it says current next. It's like save the current pointer to a temporary node. And this new node is a current, new node equals current next. It's like this new node is current next. Create one and create one connection, and this one is like that current next. So this node is a current next is this one. So first create this link, and then this one, because we save it in a temporary variable. So this new node new node next is this is very confusing. So current next dot next, because current next is a new node, right? The current next dot next would be equals to the new node next to this temporary node. It's a little bit confusing, but that's how we can add element into a list. We have to create all these connections between all those nodes. Any questions about this? No. Yeah, that's that's very these two functions are useful when I was learning programming, because we use C language. We don't we have to implement everything by hand. So we usually write this kind of function, the next something. But yeah.
First of all, when you're creating a node linked list, you have to remember the following. Add first is add to the head, add last is add to the tail. And here's how the linked list works. When you create a linked list, you have to create, for the head, you have to create a node, new node to the brand new node, assign the head to the new node.next, assign new node to the head, increment list size, and assign tail to the head if and only tail is null. And for add last, you create new element node, and then you assign head and tail to new node if and only tail is null. Otherwise, you assign tail.next to new node and tail to new node and increase the size. That's for add last and at the tail.
Yeah. So because it's this kind of structure, we can actually traverse the whole list just using next, using a for loops to start from the beginning, next, all the way, just go to the end of the list. Let's see a bonus question. We have solved the script to add node from beginning, from the middle, and you can see this is a node. This is a script for add first. We save the head and create a new node and increase the size. Then how about remove first? You can see here, this is this code incomplete. There's one statement here missing. We can get the element in the head node and return that value. Of course, we need to decrease the size of the array of the list because one element is removed. But what should we do here? To complete this code. Head.next equals to head. Let me see. Yes, that's correct. So we need, because the first one is removed, so its next is now the new head. Yeah, that's correct. So you got a bonus question come. Yeah. So we have talked about these two implementations, and the difference you can see. I mean, this is the running time of the complexity of all these different methods. Of course, because this one it use array, so get an element is O1, just give the index, you get the value. But this one, you have to start from beginning and the next all the way to the element. And also this one linked list add node and remove add first and remove first is very simple. But this one, I mean, you have to add first, right? Yeah, that's why at first you have to move everything backwards and add that element. So it will be more difficult using array list to do this kind of operations. There are many linked list questions on LeetCode. If you want to test, I mean, practice, you can definitely do those questions. And actually, these two questions, one is circular and one is double linked list. It's very commonly used to solve those questions. The only difference is a traditional linked list. The tail is, I mean, for tail, its next is null, nothing else. But the circle list, the tail is next is point to the head. So basically, you can traverse all the way, just go to the tail and go around to the first one. And that's sometimes it's useful for solving some coding question. And double linked list, it's also commonly used technique. For each node, it has the next point to the next location, also has a previous node pointer point to the previous location. So that's two variations of linked list. And also you can also use a circular double linked list. Basically just this one is next point to the head and that one previous point to the tail. I mean, that's yeah. It will. There are many complicated questions using this linked list. Feel free to do them on LeetCode. That's all about array and array list and linked list. Any questions? No. Okay. Let's see how we can implement stack and queues. Actually, stack and queues is more easier because this operation doesn't include add something in the middle. You just need to do at the beginning or at the end. So let's see this example. Let's do a recap. So a stack is just like a while or elevator. Each time we save another thing, and on top of it, maybe save another number. Each time, every new number is just a push on top of this stack. And if we want to remove an element, each time just only remove the one on the very top, and just like this way. And if it's a queue, similarly, we can, in queue is just input as a tail of the queue. And if it's dequeue, it can only remove the one at the beginning as a head node, like this way. That's the difference of stack and queues. You can see all those implementations are just based on lists, based on arrays. So also of course, we can use linked list to do that. So we can actually just using inheritance or composition to do this kind of, because all these methods are already implemented in this generic class, we can just use it directly. But it's better to use composition this time because composition allows to define a completely new class. Like it doesn't inherit everything from the other class. So some methods may be unnecessary or inappropriate for stack and queues. So we can just ignore it using the composition. The difference is if you want to use inheritance, you just using create a class and extend this class. But if it's a composition, it's just a private list. Create this, define this. Here list is actually the stack we want to implement. So we just declare this list and using the ArrayList class. And you can see the all we have to do actually is just add two functions, two methods. One is add, and it's just at the beginning of this array. And the second one, pop, it's get the element at the top of it. So we just need to get the size of this stack, and it's just at the end of the array and remove that specific element. So let's see another bonus question. How about the queues? We know that for queue, we just need to, enqueue is add something at the beginning of that list, right? Dequeue is just remove and, enqueue is add something at the end of the array, and dequeue is remove an element at the beginning. So the question is, how can you implement these two methods? Using an array, using that array list.
I can implement enqueue in the array. I can implement dequeue and enqueue. Enqueue is the linked list and dequeue is the array list.
So what's the script? Actually, you just, for both two methods, you just need one line from the ArrayList class. ArrayList class has this method for you, just need one line to.
Array list you add first. For the enqueue, for the enqueue, dequeue is you delete last. The linked list. Remove last.
Okay, yeah, exactly correct. For dequeue, remove first. Yes. Add last and remove first. Yeah, that's it. So I save it, but I think I didn't. I was supposed to remove this figure, but anyway. So the last data structure is priority queue, and we know it's very similar to queue. It's except the element has a priority there. And to solve this question, this priority is actually a sorting question, right? So we can actually using heap to do that, because we know heap the node on the top, it has it's the largest, or whatever, it has the highest priority. So yeah, I should remove this figure. I was planning to give this as another bonus question, but so you can see we can just create a heap, and the enqueue is just add an object, and dequeue just remove an object. Heap already implements all these methods for us. We don't need to care about what is the priority. It's already saved when the heap is created. Yeah, that's all for today's lecture. I think we have already finished everything. You can start prepare the final course project. I will teach the chapter 25, but it's not tested in the final project. So yeah.
When will we do chapter 25?
Chapter 25, next Monday. Sorry, next Wednesday.
What was the chapter 26 be?
Chapter 26 should be in data structure 2007.
So I will to do chapter 26 in winter semester.
Midterm?
But winter semester next year.
Yeah.
You
Yeah.
asked me to the summer.
Yes, that's right. Yeah. Next Monday is tutorial session. I will share the questions at the end of this week, and feel free to do some practice. The TA will come and will help with the questions.